there are some issues today, so I'm hoping no more. Hope everyone doing well.
Yes.
Okay, perfect. Just want to make sure that you guys can hear me. And I will keep on checking like in 10-15 minutes to just be sure on my side that you guys are there and I'm not disconnected. So last time we talked about chapter 5 and we were working on the last topic, which was binomial distribution. So let me just quickly review what we did in the last class. And from there, I will pick it up. And you must have noticed that I extended your homework assignment. But again, since we are not having class on Friday, so I'm going to extend your homework assignment until Tuesday, both chapter 5 homework and quiz. So that way, if you have any questions on chapter 5, you can check with me on Monday. So your homework assignment is due on the weekend, but I will extend it until Tuesday. So if you have any questions or any concept not making sense, then we can go over that in Monday's class or in my office hours. Or again, you are free to send me an email over the weekend if something is not making sense. We can go over that material by the email also. I had one more thing to share. Yeah. So if most probably we will be able to finish this topic, the last topic, binomial distribution today. And there is another topic here called Poisson distribution. As I mentioned earlier, that we will talk about Poisson distribution, which is the last topic in this chapter, will not be tested on Poisson distribution. So let me tell you what we did in the last class first. It got disconnected again. Oh no. Anyone has any questions in the meantime from chapter 5? And it's not. So I guess I will use my board today, whiteboard, because it's not connecting. You guys see my whiteboard?
Yes.
Yes.
Let me see. Can you read these words clearly? Can you read it?
Yeah, we can see it. You're muted right now. We can't hear you though.
So better? Now you can hear me? Okay, so let me use this whiteboard. And as I mentioned again, I'm extending your assignment by Tuesday. So if something is we will not be able to cover today, we will go over that topic in Monday's class. And if you have questions before that, send me an email and I will go over with that. So last time, what we did, we talked about Bernoulli distribution. And we said that Bernoulli distribution talks about only two outcomes. The outcome is either yes or no, true or false. So where we are talking about only two outcomes, we are talking about Bernoulli. So we call one outcome as success and another outcome as failure. So when we say one is success, so that means this is the outcome that I'm looking for. When I said failure, this is the outcome that I'm not looking for. So if I'm tossing a coin and I'm looking for a tail, then tail is my success. And then my failure is head. And similarly, if I'm looking for a head, then head is my success and tail is my failure. Similarly, you can say 0, 1. So let's say here. So success that you are looking for, and the other one is failure. So if I'm looking for 1 as my success, then 0 is failure. If I'm looking for 0 as my success, then 1 is failure. Take that way. So 1 is not always success, 0 is not always success, head is not success, tail is not success. It depends what you are looking for. So when we are talking about only two outcomes, we are talking about Bernoulli. So when we are tossing a coin 10 times and looking at the how many times I get head, or how many times I get my success, or how many times I get my failure, then we are talking about binomial trials. So binomial, in other words, you can say n Bernoulli trials. And we discussed about this in the last class, but just want to make sure that you know that. So when we are saying Bernoulli trials, so Bernoulli where we are getting two outcomes, when we are doing the same trial n times where we are getting only two outcomes, we are talking about binomial trials. Think of binomial trial is n trials, n Bernoulli trial, and when this n is 1, that is your Bernoulli trial. So you can think of either way. Binomial, if I'm talking about binomial, if it's more than 1, it's binomial, or if it's just n is only 1, then it's Bernoulli. So 1 in trial, 2 outcomes, Bernoulli, more than 1, we are talking about binomial distribution. And this n can be 5, 10, 100, 1,000, depending upon how many trials you are doing. And again, the trial should be same. If you're tossing a coin, the probability of success is 50, probability of tail is getting a tail is 50, it should be same in each trial. If you're doing 10 trials, every time the probability is same. So when we talk about binomial distribution, we have four things or four conditions that we need to satisfy. Or if these four conditions are there, we can say that we are talking about binomial distribution. And those are binary outcomes. And when we are saying binary, that means we are talking about two outcomes. And the trials are independent. We talk about independency in the previous chapter. We said that two outcomes are independent if knowing the chance of one is not going to affect the chance of other. So when you toss a first coin, you get a head. But when you toss the coin second time, or third time, or fourth time, previous trials will not affect the chance of getting your head or tail in the following trial. So the trials should be independent of each other. And number of trials are fixed ahead when you do the experiment. Number of trials are fixed. And when we are saying number of trials are fixed, that means when you do the binomial experiment, before doing that, you need to know how many trials you are doing. Am I doing 10 trials, 15 trials, 20 trials? How many? So this n should be fixed. So when you do the binomial experiment or binomial trial, you should know ahead of time how many total trials you have. And S tells you the success probability. And you can say that the failure, success, or probability of failure is same in each trial. So we are not going to say that the success probability is 40 in my first trial, but I did not get the success. So let's change my probability of success to 50 or 60. So whatever you set the success probability and the failure probability, it should be same for all the trials. If these four conditions satisfy, we are talking about binomial distribution. So how does binomial distribution work? Questions. You guys can hear me and see the board?
Yes.
Perfect. Thank you. So let's do what a binomial distribution is. So when we are talking about binomial distribution, we say that X is binomially distributed with two parameters. One is N and another one is P. Like how we did earlier, normally distributed with two parameters, mean and standard deviation, or mean and variance. And we learned in the beginning of this chapter what is a parameter, where the characteristic of a population, this is the population mean, this is the population standard deviation, population mean, population standard deviation. So when we are talking about binomial distribution also has two parameters. One is n, where n is your number of successes, or number of trials, and p is the probability of success. And when you do your binomial trial, you should know both of them. So if you know your n and p, you can find your mean, you can find your standard deviation or variance. So last time also we talked about the mean of the binomial distribution related. So the mean or expected value or mean or average is n times p. And if you can see that, if you are multiplying your parameters, you get the probability of success times number of trial. That is your expected value or mean or average or mu x or mean. So if you have a binomial distribution, you can see binomial distribution like this also. And sometimes lowercase b is also used. So they all represent binomial distribution. And you know the first one is your number of trials, and the second one is your probability of success. And when you multiply these two, you get your mean. So let me just take that binomial distribution, 10 trials, and probability of success is 0.5. Using this, can we find the mean? What will be the mean?
5.
5. This is your n. And the second one is your probability of success. This is your p. And we know that mean is n times p. So 10 times 0.5, which is 5. So once we know what my n is, what my p is, it's not hard to find the mean for the binomial distribution. When you're talking about normal distribution, you have to do some work to calculate the mean. You have to multiply their probabilities, and then you need to add those. So there you do some work. So the formula for normal distribution, we use this. And you have questions in your assignment, in your test, where you are looking for the average or the mean for normal distribution. And when you talk about binomial distribution, it's even easier. You don't have to multiply each probability with the corresponding x and add. Instead, you just multiply their n and p, their parameters. You get the mean. And let's talk about the variance. So when we say variance, and let me just remove this also. So variance of x, because x is the random variable, was p1 minus p. That is for Bernoulli distribution. When we talk about binomial distribution, we multiply with n. N is my number of trials. So if I am going to find the variance, I already found this part, and p in the mean. So I can directly plug that, or I can write it here. 10 times 0.5 and 1 minus 0.5. 10 times 0.5 times 0.5. and then you get the variance. And variance should be low. The lower the variance, the better. We have the distribution, and we talk about that in 5.2. What should we do to reduce the bias and low variability? And we say that we increase the sample size. Higher the sample size, the lower the variance. So how to calculate variance? N times probability of success times the probability of failure. And when you are talking about standard deviation, you do the square root of that. So whatever you calculate here, do the square root, you get that. So calculating the mean, variance, and standard deviation in binomial distribution is much easier than your normal distribution. In normal distribution, you need to find mean, subtract the mean, then do the square, and then times the probability. Here, just apply the formula and you get it. So that is about the mean and variance, how to calculate in binomial distribution. Now, how do we write binomial distribution, or what is the formula, or how do we calculate the probabilities in binomial distribution? So let's say if I say that probability of x equals x is n chooses x, probability of x one minus probability. This part is called your binomial coefficient. And this part is your probability of success. And this is your probability of failure. So this is your binomial distribution or binomial trial formula. How do we calculate the probabilities in binomial distribution? We can calculate the mean and standard deviation. We did that. And if you remember in normal distribution, we also calculate the probabilities, or we call it area under the curve when we talk about continuous distribution. But when we were talking about discrete distribution, we also calculated probability. There was a question in your homework, in your exam, what is the probability of x less than equal to 5.5? So same thing, we are doing it here, but that work is little tedious, little more than what we have done in normal distribution. But in normal distribution, you know that you use calculator and you can find the normal CDF and inverse normal. Same thing you can do in binomial distribution also. But again, if you understand what exactly binomial distribution is, then it's easy to use the calculator. Otherwise, because we have binomial PDF, binomial CDF, both, you need to check the time. But once you understand know what is the probability of success, because this we get it from our when we talk about binomial distribution, when we satisfy first four conditions, we have this probability of success. We say that the probability of success is same in each trial. And once we have probability of success, we can calculate probability of failure also. N is my number of trials. And we say that number of trials are fixed in the beginning. X is the one that I am looking for the probability for. So if I did 5 trials and I'm looking for what is the probability of getting 2 heads, if head is my success, then this X be 2. So let's say if I'm looking for success probability, so let's say my N is 5. Number of trials, I toss a coin 5 times, and I'm looking for my success as head. So head is my success, and I'm looking for 2 heads. So I'm saying my small x is 2. Let me write this. And I'm saying it's a fair coin. The probability of head is 50. Probability of tail is also 50. So I'm saying that probability is 0.5. If I have these three things, and this is what my binomial distribution needs. I need n, I have. I need x, I have. I need probability of success, I have. X, I already have. Probability of failure, I can calculate by subtracting. N, I have already, which is 5. And X, I have. So once you have these three things, you have everything. So if you look at the formula for binomial distribution, you just basically have n, x, and p. These are the only three things. The formula looks too big, but it just needs number of trials, which trial you are looking for the probability for, and the probability of success. If you have these three things, you can just plug in the formula and solve it. And again, we need to talk about how to solve this formula. And if you remember from the past, maybe in the middle school or high school, if you talk about permutations and combinations, and you must have learned factorial or the coefficient, we will talk about how to do that. But when we are going to do it, you may not remember that you have done that at some point, most probably in high school. And I provided that formula in your chapter 4 formula sheet also, but we will go over with that. So let's use this and plug here. So my n is 5, and I'm looking for probability. What is the probability in my second trial? So here x is 2, probability of success is 0.5. You add 2, it should n. Probability you are looking for, how many are success, the remaining are your failure one. So if your success is 2, failure is 3. When you add 2 plus 3, it adds up to 5. So that is to check if you are doing the right work or not. So this part is not hard to solve. You can solve this. So both are 0.5, 0.5 times to the power 5, and you can solve that. Anyone is writing? Guys, if you're writing something in the chat, is my free, are you guys saying that the screen is free? Okay. Is it better? Is it better now?
Yes.
Can all of you see that? If you want, I can make it more. Is it better?
Yes.
Okay. So if you're writing in the chat, I will not be able to see those messages. Please stop and let me know so that I can fix that immediately. So when you are looking for the probability of x equals 2, it is number of trials and the probability that you are looking for times the probability of success and the trials, and then probability of failure and the how many failures we have. Now, how to find this part, or how to solve for 5, 2, or we can say how to solve for binomial coefficient. How to do this part. So let's work on that. So far, any questions? Anyone has any questions about this formula so far, or anything in general? Okay, if not, let me just talk about binomial coefficient. So this says n chooses x. And this is how we say n chooses x. N is my total number of trials, and the trial that I'm looking for is my x. And the formula that we use is n factorial, x factorial, n minus x factorial. So this is how we will solve it. And what is this factorial means? Let's say if I'm talking about 4 factorial, so it is talking about 4 times 3 times 2 times 1. So 4 factorial is the sum of all the numbers, or not the sum, the product of all the numbers until 4. So 4 times 3 times 2 times 1. So which is 24. So 4 factorial is 24. Similarly, if I'm writing 5 factorial, can you guys tell me what will be the value of 5 factorial?
5 times 4 times 3 times 2 times 1.
So you can calculate that also, right? So once you know what a factorial is, you can solve it. So let's use our same problem. 5 chooses 2 and plug it here in the form. Let me write it a little bit here. And since these two are the products, so you can write it in other way around. You can write this first, this second. It's not going to change anything because in the end you are going to multiply these two. So the order when you are doing the product, it's not going to affect if you change it. So let's do this. My n is 5 and my x is 2. So let's plug it here. 5 factorial, x is 2 factorial, and 5 minus 2 factorial. Anyone has any question up till here? If not, so let me write 5 factorial, 2 factorial, and 3 factorial. By the way, 0 factorial means 1. So at some point, if you see 0 factorial, 0 factorial is always 1. It's not 0. So if you are having 0 factorial somewhere, like say 5 minus 5, it's always 1. So if we have 5 factorial, 2 factorial, 3 factorial, let's solve it. 5 times 4 times 3 times 2 times 1, and then 2 times 1. This is for this one, and this is for this one. So there are three ways to solve it. One, you can just multiply this, and then divide, or you can cross out the common part. 2 times 1, 2 times 2, and the answer is 10. So this is one way. The second way, you can cross it out. And the third way is when we are talking about 5 factorial, so if I can write 5 factorial like this also, because I have 3 factorial in the denominator. I have 2 also, but 3 is bigger, so I can stop at 3. Even if I write, it will be 3 times 2 times 1. So instead of writing this, I just write 3 factorial and 2 factorial times 3 factorial, and then you cross it out. And you can solve 2 factorial, which is 2 times 1, and then you can solve. So either you write 5 factorial as 5 times 4 times 3 times 2 times 1, or you can write 5 times 4 factorial, or 5 times 4 times 3 factorial, or 5 times 4 times 3. So you can stop it at any point. Because this factorial tells me that 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. So that you can cross the numerator and denominator, the common part, and then you can work with it. So that's how you solve for binomial coefficient. So this is the only part that you need to work on. The rest is basically the probability of success times the probability of failure. You plug everything and you get it. So this is an example for binomial distribution. And I uploaded a practice worksheet in chapter 5 module about binomial distribution problems. There are 3 problems. You can work on that. I will work on 2 more problems so that you get an idea that if we are looking for the probability of not just one event, if we are looking for what is the probability of x less than equal to 2 or greater than equal to 2, or what is the probability at least 1 or at most 1, how do we apply this binomial distribution? So far, any questions? Okay, if not, let me do another example. So using the same one, my n is 5, and I am looking for the probability of success as 60, and then my probability of failure is, so let's say I don't have a fair coin, I have a coin, buyer's coin, that gives me head 60% and tail 40%, and I'm looking for what is the probability of x less than equal to 1. So earlier we did the probability of x equals to the previous example. So we just look for the probability of x equals 2. Now if the question is asking what is the probability at most 1. So at most means the maximum you can have 1. So this, sometimes we say that at most. So if you see the word at most, so you know that that is the maximum number you can have. If the question is asking what is the probability of x less than equal to 1, so we need to see that how many trials we have to do so that we get until 1. So let's say you toss a coin. When we toss a coin, there are, how many? We toss a coin 5 times. And how many outputs we get? Maybe we get no head. Maybe we get 1 head, 2 head, 3 head, 4 head, 5 head. So we have 6 options. Either there is no head in all 5 trials, or there is 1 head, or there are 2 heads, 3, 4, or I get heads in all 5 trials. So when I'm looking for probability of getting at most 1 head, so that means I'm looking for the probability of getting no head plus probability of getting 1 head, because 1 is included. So here we are going to calculate the probability of getting no head also. When we are talking about tossing a coin, not necessary that I will get 1 head. Maybe out of 5 trials I get no head. So that means I need to calculate the probability of getting no head. And how to do that? Whatever you have done for 2, you're going to do that for this one and this one. So now here is a little bit more work. Doing the same thing, but more work. So let's do for this. So probability n chooses, let me write the formula here. So n chooses x, n is my 5. 5 chooses, what is my x here? X is 0. Probability of success is 60, and then 0. Probability of failure is 40, and then it's 5 minus 0. This is this part. And now we need to do for x equals 1 also, which is 5 chooses 1, 0.60, 1, 0.40, 5 minus 1. And then I need to solve this part, and I also need to solve this part. And that's why I told you that the probability for 0 factorial is 1. So let's solve for this. 5 factorial, 0 factorial, 5 minus 0 factorial. And then any number raised to power 0 is 1. And then this is 5. So we got this part. So let's solve this first. 5 factorial over 5 factorial. Because 0 factorial is 1, 5 minus 0 is 5. And same thing, you can do this. So this gives us the fact that when we are talking about a binomial coefficient, and if you have it 0 here, it is always 1. If your x is 0, the binomial coefficient is always 1, so you don't have to go through all this. I just want to make sure that you understand where we get this one. So binomial coefficient, whatever your n is, does not matter, n is even 1000. If this is 0, then it's always 1. And similarly, you can solve for this part, which is 5 factorial, 1 factorial, 5 minus 1 factorial, and then you can keep on pulling this one. And this will be 5 factorial. 1 factorial is 1, so I'm just doing 4 factorial. And you can solve this 5 times 4 factorial over 4 factorial, it crosses, and 5, and then you can pull this. And then so that's how you do when you are talking about more than just one. And if you think about that, we are talking about here just one, we are talking about PDF, like how we did normal PDF. So here we are talking about more than one. So here we are talking about CDF, cumulative distribution probabilities we are looking for. So when you're doing this, again, you can solve it using the calculator, how you did your normal CDF, as long as you understand what exactly the question is asking. When the question is asking you what is the probability of at most or at least, if it's saying at least means that and the probability of at least one. So that means we are talking about probability of X, one or more. So when you work with binomial distribution, words a lot, at least and at most. So if we are talking about probability, so X is 4, X is 5. So that is again a long way to do. You have to solve for each probability of X, X1, 2, 3, 4, 5. Questions?
Yeah, Professor Gold, how did you get 4 factorial again?
This one?
Yes.
You're talking about this one? Okay.
Yes.
So let me try. So here we have 5 factorial. I'm using this one. And we have, or let me just do it so that. So we have 5 chooses 1. So let me just solve this factorial and 5 minus 1 factorial, right? So we solve this and we get this one. Is this part clear up till here?
Yeah, okay. I got that now. I didn't see the 5 minus 1.
No. So does that make sense?
Yeah, it does. I didn't see the 5 minus 1. So yeah.
I'm glad you asked. Okay, so I was talking about one more thing when it says at least. So if it's saying probability of X greater than equal to 1. If I'm looking for what is the probability of at least getting one success. So when I'm saying at least getting one success, that means one success for sure. But up till one, how many? Whatever my n is. My n is 5. So I'm looking for at least one success up till 5 success. So it will be probability of X equals 1 because I'm saying at least one success plus probability of X equals 2 plus 3 plus 4 plus 5. And here comes a lot of work because you need to do for 1, do the same binomial coefficient, probability of success failure, do for 2, 3, 4, 5. Can you guys think of an easier way to do it instead of going through this longer route? And think about one of the probability rule, complement 1. If there was a probability rule when we are looking for the probability of complement is 1 minus the probability of A, right? So we can use that rule here. We know how many trials are there. So we are talking about n is 5. And what are the chances? Either we get no success or 1 success, 2 success, 3 success, 4 success, 5 success. And then we add the probability, the sum should be 1 whole. It cannot be more than 1. So I am talking about this all here. And when I add the probability of 0, the probability will add up to 1. So instead of doing this long procedure, can I just do that? That I can look for probability of x greater than equal to 1 is 1 minus probability of x less than 1. Can we do that? Are they both talking about the same thing? 1 is included here, so I'm not including 1. So it says that probability of x greater than equal to 1 or 1 minus probability of x less than 1. And which one? We have probability of x less than 1. That is only 0. So if you can solve this, subtract from 1, you get the answer instead of going through this big thing. You can solve this. This is our complement rule, the rule in the probability where we discuss what is the probability of A not happening. It's 1 minus the probability of A happening. So this is the easiest way. And let me tell you how to use the calculator. Again, you can go on your Launchpad and go under resources. There is an information how to use TI-83 to calculate binomial distribution probabilities. But what I have, like how we did using normal distribution, we did second and variables. And when you do second and wars, we use normal distribution, normal CDF as the second one. You keep on scrolling down. In my calculator, I have TI-84. In my calculator, when you keep on doing, it will do up till 10, and then it will do up till 9, and then it has 0, and then A is binomial PDF, and B is binomial CDF. Do you guys have calculator? You want to work on one problem? I guess not.
No, that would be great.
Okay, perfect. So let's do one problem using the calculator. So we do the same. So let's say our n is 5, and we are looking for the probability of success is 0.5, and probability of failure is also 0.5. And then we are looking for probability of x equals 2. So if I'm looking for the probability of x equal 2, that means I'm talking about only one probability, equal 1. So in that case, we are using the PDF, probability distribution function, for one variable. So when we are talking about PDF, we are just talking about the equal sign. So you can go to your calculator, second variable, and I'm talking about what I see in my calculator. And when you hit this one, then go to A, which says binomial PDF. And when you hit binomial PDF, it asks you trials, how many trials you have. How many trials? We have 5 trials. And then it asks you what is the probability of success, which is 0.5. And then it asks you what is the value of x. That means which PDF you are looking for. You are looking for the second probability, or when you toss a coin, what is the probability of getting 2? So probability of x value is 2, and the next it says paste, and then you hit enter, you will get some answer. And if you are working on that, and you can share your answer, so we can see that we all are getting the same answer.
I got 0.3125.
And somebody else, let me just do mine because I accidentally did 8 trials. So trials 5 probability, and I got 0.3125. Did you get the same?
Yep.
Okay. So this is how you can do it easily, but I want to make sure that you understand what is this all about. If you just plug the numbers in the calculator, I don't know, it will not say it makes sense to me, but I just want to make sure that, let's say if you don't have a calculator to solve a problem and you don't know how to do it then. So at least you know the formula, where are these probabilities coming from, and you say that your number of trials are 5, and you are looking for the probability of 2, which is something like 3.125. Is that the number? Yes. So you see that this probability will be between 0 and 1. We know that the probabilities will not go beyond 1. And if you're looking for the cumulative probability, if you're looking for probability of x less than equal to 1, so then use your CDF. So CDF will give you up till this part. And if you're looking for probability of x greater than equal to 1, I think you still do the CDF and then subtract from 1. So when you're doing the CDF gives you up till this point and then subtract from 1 to get the greater than values. And there are questions in your assignment, in the practice, in learning curve and all. So if you work on those problems, it will, or you can say binomial distribution will make more sense. And again, sometimes we cannot work with binomial distribution. When our x is very, very large, when our n and x are very large, we cannot work with binomial distribution even using calculator. Then we use normal approximation. So when we have x very, very large, and you have an example in your slide, make sure take a look at that. It says that your n is 2,500. Your n is this. And you are looking for the probability of x greater than equal to 1520. And let's say some probability is given here. So if you are applying this in your binomial coefficient formula, it will be probability of x equals 1520 plus probability work 2 days or maybe 1 day. So again, when we have something like this, we do not do binomial distribution. We approximate it to normal distribution. And how do we do that? We satisfy two conditions. If these two conditions are satisfied, instead of doing this long work, long computation, we can just check that if the probability of success and number of trials is greater than 10 and probability of failure and number of trials is greater than 10, then we can approximate it to normal distribution. And we will talk about that in Monday's class because I don't want to rush. I want to make sure that you understand this part. So we are left with this binomial approximation and one more topic about proportion. We will cover that in Monday's class. And as I mentioned, your homework assignment is not due until Tuesday, but that does not mean that wait until Tuesday. So you can start, at least take a look at the question. So if something is not clear or not making sense, we are going to have Monday's class. After Monday's class, then feel free to ask me or during the class. Thank you, everyone, and enjoy your long weekend. I will see you guys on Monday.
Thank you.